Hello everyone. In this class we are going to discuss about the block diagram reduction techniques and systems and their representation under control systems. So let's recall the last class topic before entering into the block diagram reduction. We know that what is the open loop control system and closed loop control systems. So the open loop control systems in this the output is which does not affect the input of the system. But in closed loop control system, there is a feedback element is available. So the output is influences the input through the feedback element. So we can get the correct output with reduced error in closed loop control systems. So before entering into this block diagram reduction techniques, let's discuss with something. In control systems, we often represent a complex system using block diagrams. So each block represents a transfer function and arrows represents a signal flow. But what happens when the system becomes complicated? When it has a multiple feedback loops, many interconnected blocks and several summing points means the diagram becomes too difficult to analyze this directly. So that's where block diagram reduction techniques help us. The main objective of block diagram reduction is to simplify a complex block diagram into a single equivalent transfer function. So let's discuss today's topics for discussion. Basic rules of block diagram reduction for 1 to 5. And additional rule 6 to 11 with n advantages. So let's explore DT empathize part of this topic. First, we should identify system components. So what are all the components available in the systems and interconnected elements and number of feedback loops. The next part, the simplify block diagram using block diagram reduction rules. So reduce a complexity to a single transfer function. Next one is analyze system behavior, that is evaluate system performance and stability, and design a control strategies with develop effective control mechanisms, and implement control system with apply designed strategies in a real world applications. This is the one cycle of DT empathize part of control systems using block diagram reduction and the real world applications. So now explore the basic rules of block diagram reduction techniques. The rule 1 is combining the blocks in cascade manner. So the magnitude is represented, input is represented as A and our gain is G1. After that we can get the output as multiplied with A into G1. And the input for G2 is A G1 and we can get the output as A G1 G2. So we can simply combining these two blocks G1 and G2, we can get A, the gain is G1 in G2, the output is A G1 G2. So this is the result of cascading the blocks. The rule 2 is combining parallel blocks or combining feed forward paths. So the A is your input and the summing point is available. And G2, G1 are the gains. So from this we can get A G1 and A G2. Here we can have the summing point with a plus symbol. So we can add this to A G1 plus A G2 is equal to A G1 plus G2. So we can easily replace with A gain is G1 plus G2 in a parallel path. So we can get A into G1 plus G2. And the rule 3 is moving the branch point ahead of the block. So this is a branch point. Here a magnitude, after that branch point, after that we can get the gain block. So the output is AG. Here the branch point output is represented as A. So if you want to move the branch point ahead of the block means we can get A, G and then branch point. So we can get A, G is your first output, but our second output is A. So we can divide the gain in this block. AG, if we divide 1 by G means we can get the output as A. Rule 4, moving the branch point before the block, so that is A gain block and the branch point is AG. So if you want to move our branch point before the block means it is branch point A, we can get the output as same AG and AG. Fifth rule is moving the summing point ahead of the block. So the summing point is A, B, then this is a plus symbol, so we can add A plus B and the block A plus B into G. So if you want to move the ahead of the block means the summing point is moved AG, BG and the summing point. So we can get BG, AG in a plus manner. So the common gain is outside, so A plus B into G. Rule 6, moving the summing point before the block. So the gain block is available and the output is AG and the another output is B. We want to add this, the summing point AG plus B. So before the block means we can transfer into before the block. So our input is B only. So B 1 by G and we can get the B by G here. So the output is A plus B by G. After multiplying with your gain, we can get the AG plus B. Rule 7, interchanging summing point. So the summing points are interchanged means here A, B, the summing point is plus. So we can get A plus B and A plus B plus N minus. So the C input is with minus A plus B minus C. So if you want to interchange summing point means A minus C and added with the B block A minus C plus B, that is equal to A plus B minus C. There is no change in the output. Split same like that, splitting summing points A, B, C, the A plus B minus C and then A plus B and minus C. Combining summing point means A plus B minus C. Here we can combine A, B, C, the A plus B minus C. Rule 10, elimination of negative feedback loop. So this is R minus CH, the feedback element, into G, R minus CH into G, the output is C. So here the feedback element is CH and CH. So we can write it as R and the output is C. So write transfer function G by 1 plus GH by using the simplification. Rule 11, elimination of positive feedback loop, same like that, it is R, G by 1 minus GH. These are all the rules of 1 to 11. The exercise is reduce the block diagram shown in figure and determine the transfer function. Let's summarize this class. So we can recall with open loop and closed loop control systems and with the block diagram reduction techniques, importance and their analysis and rules of block diagram reduction techniques from 1 to 11 and the applications of block diagram reduction techniques. And let's summarize. These are all the references of this topic. Thank you.